Great. And I'll make a list of these things as well. There we go. All right. So here, we don't have quizzes, or we haven't had quizzes. So I'm going to propose changing the contract, but because I'm changing it, doing it in a way that would best work for every student. So this 10% that would have been for quizzes, I'm going to raise whichever of these is the highest score for you. So if you have a highest score on your homeworks versus your midterm final term project, then I'll just give this 10% to your homeworks. Or if you really knocked out the midterm, then the quizzes can go there. Whichever way will help the individual student. So because we haven't had quizzes. So I want to make sure that these are okay with everybody. And if not, you can message me privately or anything. But I do want feedback for this. First of all, is that amicable to people? Yes, you like this idea. Okay, so merge quiz weight to highest other category. Yeah. Okay. So the exam. We have an exam and a term project. So another thing that I needed to try to figure out by actually talking to a human being, apparently, is when exactly is our time slot for during final exam week. There's this website, finalexam.rutgers.edu, which, by the way, if you try going here yourself, you might get some security warning. You can just accept the risk and continue. Basically, people at the IT department aren't keeping up to date with their security certificates, but I trust that this is actually the Rutgers website, and I'm not being scammed. So here is our class. Here. So 33, 136, 470. 33 is the administrative code. It basically says that it's the business school. 136 is the course number, and here, this 5-digit code is the section number. So the class course code is 136 for this class, and here is our index, and when I search, there's no results. Here, if you go to New Brunswick, they have a final exam grid that should be more detailed. And this is the grid. So we are a Tuesday, Friday class from noon to 1:20. Here is a Tuesday, Friday class, for example, but that's from 11:30 to 12:50 on December 21st, that Monday. Anyway, if you look around this grid, I don't see where our time slot is supposed to be. That being said, the time slot I don't think should matter as much, because that's just when I would like the final project to be due. I want to make the final project due the week of final exams. So here, not here. Great. This is the semester, and classes end December 10th. There's the weekend and Monday for reading days, and then exam week. So reading days are days where if you have an exam during exam week, then you can dedicate your time to studying for that exam. Other exams, like take-home exams or final projects, can be assigned before the reading days, and then the reading days can also be spent working on those things, and then they'll be due the final exam week. The latter is what I'm proposing. So the final project, I'm going to be recording basically an extra lecture. I'm not going to be giving it, nobody has to attend it, but over the break, I'm going to record another lecture and make it available about how to get started with this project. And so you'd have, I don't know, 2 or 3 weeks to work on it. Will the exam be take home like the midterm? Yes. So what I propose is this. Let me, no, I don't want the whole thing. And if everybody agrees to this, I'll update the syllabus as such. So one, we wait best category 10% to replace quizzes. Okay, so this is today, November 24th. This day, November 30th, that's homework 2 is due. This is the last day of class, December 10th.
So we can see the screen.
Oh, you can't. I'm sorry. Okay, now you can?
Yes.
Okay. So here's today, November 24th. The homework is due next week after break. And this is December 15th to the 22nd. This is final exam time. Now, I need to check with a human being, I guess, about if it matters when specifically this class is going to be meeting or anything, because like we're not going to have a timed exam. But this time, the final project is due. I'm fine with the final project basically being due as late as possible, although I would still encourage people to finish it as early as possible so you can enjoy Christmas or Hanukkah or whatever. Okay. Now, for the last exam, The last exam is going to be comprehensive, so it's going to be everything that we've learned this semester, from the background to ER diagrams, and then finally uh, relational algebra and SQL queries, but it will be more heavily weighted towards SQL. It might just be like one question from, or a couple small questions or something from previous things. So it will be much more weighted towards the latter half of this semester. And what I would like to propose is this. Last exam released, and here exam due. So you'd have a really long time to work on the exam, but I would be giving it before exam week. Exam week would be when the final project would be due, and that would give 2 or 3 weeks to work on the final project, which I think would be more than sufficient. So for the finishing up the semester, are people okay with this? Okay. So I will update the syllabus sort of with, I don't know, amendments, whatever, and I'll write this. So, okay, good. And so starting today, we're going to be talking about SQL. It'll take just a couple of lectures to get through all of it. It's really not that bad. I mean, the relational algebra queries is hard, I think, because you have to figure out how to write the query. But once you have it in, like, if you can do it in relational algebra, it's just a matter of syntax to make it a SQL query. Okay. All right then. Then, if there's no other questions, we can get on to SQL. SQL itself. Oh, when will the directions for the project be sent out? So probably after break. I mean, I'm going to be recording a lecture and maybe putting together like a document or something for, I don't know, that outlines certain milestones of it, this kind of thing. Yeah, part of, a group project or individual project, that's right. So, okay. I'm okay with people working in groups. Somebody in the other section asked if it's okay if somebody from that section works with somebody from this section. I think that's fine. Yeah, there's no problem with that. So if you know somebody in the other section and you'd like to work in a group there, that's fine. But I will say this: somehow, if you're working in a group, the work has to be more substantial than an individual. Because if an individual does a project, then they are limited being an individual versus a group of people who are working on something. So um, uh, the bar for a group project is a little bit higher, or otherwise, I think just to keep things fair, the bar should be a little bit lower for an individual because they don't have the benefit of a group. I don't think group sizes of any larger than 2 or 3 makes much sense, unless if you're very adamant about that, then talk to me and I can adjust the project for those particular larger groups. Will you be presenting the projects? Uh, yeah, there might be. I hope that there's time for this, uh, especially if people can finish early. But I don't know that that would be a mandatory thing, because if these are going to be due the week of final exams, I don't know what your other exam schedules are like, and um, uh, then I'd have to schedule a time for each person, or schedule a time for everybody to meet, and I'd rather not make that a requirement. So, um, okay.上课，上课. Okay. So, great. Okay. Any other questions? Okay. So, oh, will we be meeting tomorrow as well? Hold on just a moment. Um, um, Regular classes of Friday will be conducted Wednesday, November 25th. Yes, so I guess we will have class tomorrow. Yeah, 12 to 1:20. Right, this will make up for the class that we missed at the very beginning of the semester. So yes, same time. Um, okay. Where is me? This, you guys. So this is from the administration, just saying that, yeah, yesterday, today, regular classes, Wednesday classes get uh, canceled, and Friday classes get moved to Wednesday. Okay. This one. This. Okay, so this is actually using some examples from the textbook, just to make things a little bit more abstract and different. These are three tables, R1, S1, and S2. And R1 are, so SID is a sailor ID, and these are tables about sailors. So they have names like Dustin, Lubar, Rusty, and Lubber. Oh, actually, I think this one should be Lubar as well. Yeah. And so first, let me pick on a student for kind of an easy question. This will be how to do a relational algebra query. Should be an okay one, I think. How about psi? Psi Saka? Mic not working. Okay, no problem. This should be a short query, so you should just be able to write it. Return the names of sailors from S1 that are older than 48. Okay, so what is the relational algebra query for this? Select S name from S1 where age is greater than 48. Okay. This off. Uh, ah, okay. Yeah. Uh, I'm going to get to this. You are mixing up SQL and relational algebra. Here you say select S name from S1 where age is greater than 48. Yeah. You're selecting the people whose age is greater than 48. This is what you wrote. Which is good. I was going to make a point about this. I'll still make it. I'll just make it later. And from this, we want to project the name. Okay, so from this table S1, we select those with age greater than 48. So these get eliminated, and we return the name. So this would return S1 S name text with a single entry lubar. Sorry. Okay, great. Well, my next question was going to be for people who are maybe more familiar with SQL, how would you write this in SQL? And I'll take what you wrote, select S name from S1 where age greater than 48. Oh, okay. Good. So SQL has this type of syntax. Select from where. The select, the SQL select, This is a projection. This is pi, select. Actually, it's close to pi. It's not quite pi yet. I'll get to that. From this is well, actually, maybe I'll get back to that. I don't know. Here, the where, this is the select sigma. This is SQL, and this is relational algebra. So this is what I mean when it's just a matter of syntax. Instead of the select for relational algebra, SQL calls that a where. The SQL select is actually the project in relational algebra. So I think the idea here is I want to select these columns, but relational algebra is more of a high dimensional thing where you project vectors into lower dimensional space. In any case, be careful not to confuse this select with that select. The SQL select and the relational algebra select are two different operations. They're equivalent. Everything you can do in SQL, you can do in relational algebra and vice versa, which is why we went through relational algebra first, because it's a little bit cleaner than SQL. Okay, let me ask you guys, what do you think? So I've given you two of these. The select is the project, the where is the select from relational algebra. What about the from? Does anybody have an idea what that is? The table's being multiplied. Excellent. Yeah, this from is the cross product. Now there's the other primitives, and we'll get to those not this lecture, but the next lecture, where you have union and set difference, intersection, these things. But yeah, remember, there's only 7 basic operations. These are already 3 of them. Except for this. The project. This select is not quite a project. And I'm going to come up with a list of things that you have to do this course, in this course, for this course. One of them I've already talked about, so. Things you must do in this course. That is, will only get full credit if you do these. So you could do something equivalent, but you might not get full credit. So there's a couple, or there's like maybe 4 things. One we've already talked about. Don't use join. Do the low level. query instead. This, this one, you can graduate to join after class. So what I mean by that is, I think that join is something that a lot of people don't actually really understand what's happening. Be it with the natural join, with the left join, with the right join. And people just sort of use it like it's magic, like it's just doing this thing. And because they don't quite understand what's happening, they make mistakes. So for this class, you're not allowed to use this word, join. In the same way, for relational algebra, we don't do this. We do a project and a select, and we cross multiply things with a rename, and we do it this way, not this way, not this way. Yes, this is shorter, but this actually tells you what's going on. And so for joins, you do it the long way. The second thing is use distinct. This is something that I think, well, not only for this class, you have to do it for full credit. The reason why I'm doing these things is to avoid, I mean, you guys are sort of, you're undergrads, right? You're in training. At some point, you're going to be out in the real world doing things. And I want you to do them well or not make mistakes. That's distinct. Distinct. So let's go up to this query here. For the relational algebra query, I've emphasized that things, when they're returned, there's no repeats to them. You can think of them like a set. And so when we do this operation, again, we're doing it on S1. We're selecting those ones, those entries where the age is greater than 48. So we don't select either of those. And then we're projecting this, but here, Lubar appears twice. And in sets, that doesn't happen. And so this is the result. We just want the name Lubar. That's the way the relational algebra works. This SQL will return this. Because from table S1, from this table, where age is greater than 48, so not these, select this column. And this keeps both of them. When you add distinct here, then it will return this, just the one Lubar. We want all of the distinct results, not repeats. And most of the time, you don't want repeats. So you should always use distinct, unless you have a reason not to. If there's a reason why you want repeats, then don't use distinct. But then you also have to have an explanation about why repeats were important for this query, that you wanted the repeats. So use distinct unless you have a reason not to. If you want the same record returned many times over, sometimes you do want that. But most of the time, I think you don't. So, yeah, if the query is meant to have no repeats, then you should always use distinct. This, I think, would be good industry practice, and I would encourage you, even if you're in a place where they don't do that, you should advocate for it. Okay. So use distinct. Oh, really quick. There's no reason why these words have to go in this order. Select from where. In fact, I would have preferred it like this. From whatever, where, whatever, select. Because that sorry. This way, if you said from where select, this more closely matches sort of what's happening here. So from this table where this thing is true, project these things. In any case, although it doesn't matter, you can write it any way you like. The sort of I don't know, standard has become this. Select name. This name. Oh, come on. Do this. Okay. This I don't really think you're going to be able to get around, and people already write queries this way, so just get used to it. That's the typical fashion that it's written, select from where. If you write it a different order, I'm not going to take off points. I'm just saying you'll usually see queries in that order. The third thing is which I want to mention first. Okay. Actually, okay. I'm not sure how to do it. Let me copy these again. All right. This star, so basically instead of doing this, sname, that would return just a column sname. This instead returns all of the rows. So the star is just like an anything character, everything that matches. So return in this case, this entire thing with in this case, this would return both of these loop bars because they differ in their rating and age. So, okay, the problem with this is that in the real world, things change. You have different groups of developers working on different parts of a program. You have some people who are working on the database. You have other people who are working on the web platform part of it. And they don't really communicate all the time, or they make assumptions. And, you know, people who are working on something, setting things up, they'll leave the company and whatever. Things change. So writing a query like this can be a problem, because let's say that if you call this, and maybe the guy on the web is now expecting to see an SID, an S name, a rating, and an age. So that guy hard codes these things. He makes a query one time, looks at what the fields are of that query, and decides that, I don't know, on the web page that he's making, he's going to be looking for these specific names because he tried it once, those are what were there. And that's the way that his interface is built. Now, later, people on the database team decide, you know what, this rating here, we don't like it being an integer anymore, you know, like Netflix, when they decided we don't want a star system anymore. It's thumbs up or thumbs down for a movie. Do you like it or not? There's no gradient in between. Not a fan of it, but Netflix did that, and so you know, maybe they say, okay, so now these aren't going to be integers. This is going to be like a bit, and this is, you know, going to be thumbs up or thumbs down. So this is going to be replaced with something else. And now, let me make this a bit different. Same thing, I'm just gonna, whatever. So these people, they decide they don't like this rating system anymore. They're gonna get rid of it, and they're gonna call this, I don't know, good, bad. And that's a bit. And this is, it can be, you know, thumbs up or thumbs down. So thumbs up, thumbs down, thumbs up. And now, when the guy working on the web page is trying to query the database using this, because this is what's behind, he will now be returned this thing. So there is no rating, and there's an extra thing called good, bad. But he hard-coded these names, which means that now the website's broken, things aren't displaying correctly, and what's going on? And now people are trying to figure out, like, why is this web page down? Like, why isn't it working? And this can be kind of a hard to track down bug. So it's a bug, and these things happen. So in order to avoid this, this is the third thing that I'm going to be asking everybody, is don't use star. If you want to return everything, then you explicitly write everything. You want S1 name, you want S1 S name, you want S1 rating, and you want S1 age. Okay? This way, if somebody goes here and gets rid of that and adds this, you know, good, bad, whatever, Now, this query is going to break because there is no S1 rating. This is going to be missing from the query. So now this query will throw an error. And you can catch it. You can tell, because now the query is broken and the database is throwing errors where the error happened. It's happening with this query, and then you could find this. Okay. Otherwise, that could be a very nasty bug that's just hard to track down. So many things break for so many different reasons. Make your life and other people's lives easier by being explicit when you want things. If you're debugging or whatever, fine, use star. But for anything production, be explicit.
Wait, Professor, I have a quick question. Would you start, when you start, would that give you rating, including or not? Or would that also get rid of rating? Or like, does star just do everything that you would implicitly?
Star returns whatever is here, whatever is there. So if they got rid of rating and now it goes good, bad, this query would break with this change down here. This query would not break this one. It would instead return a tape. It would return SID, SName, age, and good, bad. So this query would works, this query breaks. But in this case, we want it to break, because if this avoids other people who, people are lazy and they try to take shortcuts and stuff. And so they might hard code, somebody else might hard code these values, or that they're expecting to see a name, an S name, a rating, and an age. And the web guy, he wants the rating. He knows that it's a number that ranges, and so he's going to be displaying that differently with, I don't know, a bar or something, like some number of stars or whatever. He'll be displaying that differently. So he might just hard code that that he's expecting this. So now when the database guys make this change, the web guy doesn't know about that change, and he's now using this query, then yeah, it will return a result, but it's going to make the website break, because the website is expecting a rating, and instead they're getting something extra and the rating thing is missing. Does it make sense? Like this query will work, but you don't want it to work because things are changing. This is a way to keep people on the same page. Yeah. So this is for like production code. If you're debugging, whatever, like make your life easy. Does that make sense?
Yeah, thank you.
Okay. Yeah. So that's to avoid bugs. The fourth thing is to rename your tables. Okay. This is also to avoid bugs and to bugs that are made by people who are writing the query. This query happens to be very simple. Some queries, as is the case with relational algebra, they can get kind of long and complicated. And it can be easy to mix up which table is what. And so you can make a mistake writing your query because you're getting tables mixed up. There's too many of them and stuff like this. So here, I'm I'm going to ask that you rename your tables and always reference from which table you want this thing to come from. Yes, you might be able to leave it out. Again, you could write this query and it would probably work. It, in many cases, might return, certainly with the distinct, it would depend. But sometimes, depending on the table, that will return the same thing. But while this is okay for small queries, when queries start getting more complicated, again, being more verbose will help avoid error. So these are the 4 things that for this class you have to do for a SQL. The first one, the only reason for that is because I think that people should actually understand what a join is doing before they just start using the shortcut. Once you understand it, great, do the short thing. But in my experience, too often people don't really understand it and just kind of use it like magic. So after this class, use join all you want. The other 3, I think, are useful things just in general, and they're good practice. And if you're in the real world, these things should be sort of standard. If the place isn't doing them, then you should advocate for them to do it, because it can save you a lot of trouble. Okay. Any questions about any of that? Okay, guess not. Okay. So I want to look at a few relational algebra things and see how to translate them. We've already seen one. This next one, actually, I'll write this down. R1 times S1 for these tables. I guess, yeah, you should probably know enough now, maybe. How to write this in SQL. So you're going to have a select from and a where. Okay. So I'll give you, I don't know, 2 or 3 minutes. So try to come up with this, what this select should be, or what this, how do you do a cross multiplication between tables R1 and S1 using SQL? So I want you to fill in these dots. So I'll give you 2 or 3 minutes and check in. Okay, anybody think they have anything?
Professor,
Yeah.
is the syntax for multiplying tables by each other similar to the syntax of multiplying rows or rather numbers together? Meaning the cross product, is it a simple dot?
So I'm trying to understand your question. First of all, this and this are not the same. Well, this symbol exists in relational algebra. This symbol does not exist. So in that sense, I mean, you cannot write R1 dot S1. I mean, that doesn't make sense in relational algebra. Yeah. Let's see. And as far as the multiplication, yeah, it's a set multiplication. So it's finding all possible pairs. Do you know what the result of this would be? This R1 cross X1?
It would be where 22, oh, rather no. It would just add a R1 to every element of S1, I believe. Meaning the 22 to Dustin and then 22, the R1, everything in R1, like one by one added to S1 table, I think.
Everything in R1 added to the S1 table.
Meaning
How many
concatenated. The table is being concatenated together.
concatenated together? Um, so how many columns are there in the table?
1, 2, 3, 4, 5, 6, 7.
7. Okay, that's good. Hang on.
Is that right?
Yes, there are 7 columns. And how many rows would there be?
It'll be 1, 2, 8, I think.
8. Very good. Yeah, wonderful. All right, yeah. So, great. Okay, yeah, then you understand how it works. Yeah. So this one gets paired with each of these. So whatever, SID 21101 would get paired with Dustin. Oh, so stupid. Yeah, he'd get paired with Dustin 745. He would. This guy would also get paired with Blue Bar. Right. And on and on. Okay. And then there'd be 8 rows altogether. Oh, one more thing. Here, yeah, there's a bit of a problem here. Okay, anyway, yes, very good. So that's the way that the regular cross multiplication works. Does anybody have how you would write this in SQL? without join. Well, one, yeah, here you can never use join. That will be my next question. But two, this is not a join. This is a cross multiplication. Okay, I see select star. Already you've lost points. No stars. Okay. I'll give this example and then, yeah, maybe we need to see some more examples. From R1 and S1. Yep. Let's see. Okay. So I'm seeing this R1 dot SID, right? R1 dot BID, R1 dot day, S1 dot SID, S1 dot SName, S1 dot rating, and S1 dot page. Again, be explicit about all of them. Yes. Okay, that's better. Anything else? Or is this it? Where? Yeah, do you need a where? Or what do you put there? SID equals SID. Okay.
Nah. Roll on your test burn. I don't even go get tested now. Think about it.
To you.
Dude, they're probably so overbooked right now that test would probably
And
Thanks.
somebody.
Because I know like they have off like all the Rutgers buildings are.
Okay. Distinct also. Yes, thank you. So you need distinct for full credit. This is SQL done right. Okay, here, this way. This is what I'm trying to enforce. These, at least these three, this is SQL done right. Okay, so you can do it other ways. Please try not to. Well, not only please try not to, but if you want full credit in this course anyway, you have to do it the right way. The right way. Okay. Also, we have to rename tables. So from R1 as R, and I'll do this, S1 as S. Here, this is a problem, SID and SID. So, okay, we're starting to get things a little mixed up, maybe. For the R1 cross S1, let's go back to look at this relational algebra for just a moment. One problem that we discussed before is that here we have two columns with the name SID. So that was sort of problematic because when you try to reference column SID, you don't know which one it is. So we would have this rename, SID to, I don't know, SID2. And we'd rename that. So these tables actually already have these labels. So you don't have to explicitly rename them. But you should know that by default, each of these do actually have, if you don't rename these, here, and I'll get rid of that where for a moment. If you don't rename these, it will still result like this, which is why you can reference this SID being different than this SID. That is something that happens implicitly in SQL, but in relational algebra, it's something that you have to make explicit. In any case, that's the renaming of these columns here happens implicitly. You can also explicitly rename columns, but whatever. So here there's an implicit renaming. I still want you to rename tables anyhow, and that's not for this renaming columns thing. The renaming tables is for you, the person writing the query, not to mix up which tables are what. I mean, even if you say R1 as R1 and S1 as S1, if you don't want to rename the table, you still write that. Yeah, I think that this is a convention that you should just use, and it will, at times it's excessive, but if it's a habit, then you will avoid other mistakes later. So I believe, which is why I'm enforcing it for this class. Why make my life hard like that? In which case, all of these would be like this. I saw an earlier message. Oh, this SID equals SID. Just write this. By the way, the double equals, this test for equality, that's a Python thing, or other languages thing. In SQL, this isn't setting one to the other, it's checking to see if they are equal. But there's a problem here, SID. Which SIDs? R.SID equals S.SID. This is incorrect. This is a join. This is R1 join S1. Where you're finding where the sailors that exist in one table also exist in the other table, which, by the way, when SQL does have a join. When I say don't use join, what I mean is instead of join, write it this way, because that's what's actually happening. After this class, you can just use the join word. That's fine.
Sorry, Professor, can you explain the from section again? I'm really confused with the SR and the SS. Like, what exactly that does. Like,
Okay.
when writing the query.
Yeah. So it's renaming the relation. So here, what that does is it takes this table, R1, and we're going to rename it R. And this table, S1, we're going to rename it S. That's what the as does. From both of these tables, actually, here we just need S1 is S. The from here is doing a cross multiplication. So it's taking this relation that's now been renamed R and this relation that's been renamed S and doing a cross multiplication. The result of which, now these would just be R. The result of which is this thing. This is R times S. And there's 7 columns, 1 column for each of R and 1 column for each of S. And then the number of rows is 8, because this will get paired with these 4, and then the second one will also get paired with their 4, and those will be the 8 columns. For example, the first row is that pairing, the second row is that pairing, and then the dot dot dots are the other 6 pairings that I'm just not writing. Why is it necessary to rename the tables? So again, this isn't, here it doesn't change anything about the query. It's a habit that I advocate for. The habit is to rename the tables so as not to confuse yourself. And I'm enforcing the habit by saying that do it every time, even if it's not necessary. Like here, it's not necessary. In fact, it's never necessary. But when you're writing very long queries, then it's easy to get tables mixed up, which one you're referring to, especially when you're dealing with lots of different relations. Right now we're looking at very simple relations, so it just sort of seems like, I don't know, extra stupid stuff. But later, I think it is a good habit to have, such that when you're dealing with more complicated queries, you're less apt to make mistakes. You could write the exact same query without renaming anything, and it would not be a problem. The reason why it exists in the language is to just help avoid human confusion.
Wait, Professor, real quick. I'm trying to understand like why we would get confused. Like, what would be wrong with using the original's name and then like sticking with that?
Well, here again, I'm naming these tables. We're dealing with a very small number of relations, and hopefully we can name them something sane. But if you're working on an existing database, you might not have control over how people have named their relations. And sometimes the names aren't appropriate, like that's the name of the table, but it's not really describing what the table is at all. Because again, yeah, things change, people don't design things quite right. And so by renaming them, you can, oftentimes it makes it a little bit shorter, because some relations can have really long names. And so it helps you be lazier, because you can assign it a single letter or a single small word or something, and so that's less typing for you. The other thing is that sometimes tables aren't named very well, and so you have the opportunity to name it something that you like, and that way you can keep it in your head. I mean, however it is that you want to think of this table, give it a word or a letter that represents that. So again, I mean, all of these are human features in the language for humans. This has nothing to do with the success or failure of a query. It's just good practice.
Okay, that makes sense. Thank you.
Mm-hmm. Okay. Yeah. I'll let you think about this, what to do with this where. If you say r.id equals s.id, then that's doing a join. This is a natural join, which is different than a cross product. So I'll leave that for you to think about, and I'll see you tomorrow.